Alright, dear children, now we will go to the next topic of this chapter, vibration of stress string. Okay, now the topic that we discuss is the laws of vibration of stress strings. Now, whenever the stress string vibrate, it vibrate in the form of what wave? Standing wave or stationary wave. Okay, but the frequency of vibration, let me just tell you, the frequency of vibration of a stress string that we learned in last YouTube video also depend upon number of factors. It depends upon the tension acting on the string. It also depends upon the length of the string. It also depends upon the mass per unit length of the string. So these factors are only expressed in the form of laws. That's why there are basically three laws for the laws of what? Vibration of stress string. So number one law, that is nothing but law of length. Law of what? Length. Now the law of length, say that for a given string is also, we take as wire, under a given tension. Under what? Given tension, the frequency of string, the frequency of the vibration of the string varies inversely as its length. Varies as inversely as its what? Length. And this length is also called vibrating length. Because when the length string vibrate, it vibrate to a certain length. Okay. Because string are usually connected with the two end with the rigid support, okay, stress string, okay. So under this case, whether you take a length of shorter length or longer length, okay, the string will vibrate with different frequencies, and the frequency of vibration of string instrument, or the stress string, depend upon the length. But how it depend? Inversely proportional. Means smaller the length, larger the frequency of vibration. Larger the length, smaller the frequency of vibration. But this is true for a given string under what? Same tension. So children, whatever statement I said just now, the same statement I have written in the words also, okay. So that is, for a given string or wire under a constant tension, the frequency of the string varies inversely at its vibrating length. Vibrating what? Length. Which means your frequency, if I mark by letter nu, okay, is inversely proportional to 1 by what? L. And L is the symbol we use for length, and nu is the frequency symbol we use for frequency. But in fact, you can use N also. Okay, you can use symbol N also, or you can write N is proportional 1 by L, same symbol. Or F can also be used as the symbol instead of what? Nu also. Okay, so any of the symbol can be used to express the frequency, but the frequency and the length are inversely proportional to each other. Okay, stress string of shorter length vibrate with large frequency. Okay, stress string of longer length vibrate with less frequency at a given tension. So this is the first law of vibration of stress string, and this law is called the law of length. Similarly, we have next law, and this law is also called law of tension. Now we have law of what? Tension. Now frequency of the stress string, vibration of stress string, also depend upon the tension. But this is usually for a given length of a wire. This is for a given length of a wire. And the law of tension says that for a uniform string means having same thickness, having same area cross section, okay, of given length, the length must remain same, and material, and that means the string should be made up of same material, okay. The frequency of the string is directly proportional to the square root of its tension. Square root of its what? Tension. That means the frequency nu is directly proportional to the square root of what? T. And you know T is the symbol we use for tension. And tension is also a force acting on the string, a reaction force acting on the string. Okay. Now, frequency and the tension are directly proportional to each other. Means if you increase the tension in the string, the frequency of the vibration of the same length of the string will also increases. More tension, more frequency. Less tension acting on the string, less frequency of vibration. But this is true for a given length of the string, and the string should be of uniform length or thickness and of same material. So for uniform string of given length and same material, the frequency of the string varies directly proportional to the square root of its tension. Okay, that's why nu, the frequency is directly proportional to square root of T. T means the what? Tension. Okay, now if this is true, then for a given length of the string, we can increase the frequency of vibration, the mode of vibration of the string by increasing the tension. Okay, if we increase the tension, if we make the string tight, more tight, then what happens? The sound produced with larger frequency. That means the frequency of vibration of the string increases. Okay, so this is nothing but the law of tension. Now we have the last law that we need to discuss. That is called the law of what? Mass. Law of what? Mass. And the law of mass says that for a given tension, the tension remains same, and even the given vibrating length, the length also remains same. Now for a given tension and given length of a vibrating string, okay, the frequency of vibration of the string, see, the frequency of vibration of the string varies inversely as the square root of its mass per unit length of the string. Means the frequency being marked by letter nu is inversely proportional to 1 by square root of mu. And you know mu we have last time used as a symbol for mass per unit length, or we can also write frequency is inversely proportional to 1 by square root of what? M. So see, children, no confusion out here. Let me just tell you, mass per unit length can be symbolized by letter M only, or it can be written by nu. Okay, any symbol you can use. But the frequency and the mass per unit are inversely proportional to each other, which means smaller the mass, amount of mass in a given length, okay, more is the frequency of vibration. Larger the mass, amount of mass present in a given length means, okay, less is the frequency of vibration. Now this is just due to the thickness also. Suppose you have string of different thickness. Okay, in a given length, if the string is thicker, then that string at a given length has more mass. Okay, then the string which is thinner at a given length. So what happened? The thinner string will vibrate with more frequency, where thicker string in a given length vibrate with less frequency. Yes, because the amount of mass present in length of the string is more than the amount of mass present in thinner length. And more the mass per unit length, smaller the frequency, and smaller the mass per unit length, more the frequency. That's why the law of mass says that for a given tension and a given vibrating length of the string, the frequency of vibration of the string varies inversely at the square root of mass per unit length. So this is a relation that express the what? Law of mass. So basically there are how many laws for the law of vibration of the string? 3 laws. Okay. So these laws that we have discussed in details. Okay. Now we will be applying these laws also, okay, in the next topic, that is the standing wave in a string fixed at both ends, which is also called no mode of vibration produced in string.